How do you charge an air conditioner? Step by step for beginners. You're brand new, you got your gauges, you got some tools, but you don't know anything about charging an air conditioner. Today, I'm gonna give you the tools that you need, show you how to visually see if an air conditioner is low on refrigerant, know what the symptoms are before you charge it, and then how to charge it successfully using methods like superheat and subcooling. You're watching HVAC Tips for Technicians. I'm Tad, this is Taddy Digest, let's go. First, you gotta have the right tools. So get some psychrometers, get some temperature clamps, and get a good set of gauges. Before I show you how to charge an air conditioner, I'm gonna show you what it looks like when an air conditioner is low of refrigerant. Let's start with our first method. Let's hook up these gauges and show you how to do it. We've got a split unit right here, and I've got my gauges. The gauges have two different sides. One side is usually blue, and this is your low side. This is your suction pressure. And then we have the right side, which is our red side, our high side, discharge pressure. We've got a blue hose that comes from the low side and a red hose that comes from the high side. We hook up the low side with the blue hose to our suction line service valve or vapor line service valve to the access fitting. Then we hook up the red hose that comes from our high side and we hook it up to the liquid line service valve to the access fitting. That's how you hook up your gauges. Diving into our gauges, we can see when they're hooked up, the standing pressure or the running pressure. The standing pressure is the equalized pressure when the system's not operating or running. The running pressure is obviously when the system's running. So if you hook up your gauges and you don't see any standing pressure when the system's not operating, then it could be that your system doesn't have any refrigerant. A good visual way to see if the system's low is checking the suction line or the vapor line. If you see a bunch of ice building up on this line, it could be the system is low. Where does this ice start? Let me show you. This is where the ice forming starts on our indoor coil, our evaporator coil, and you will see that this whole entire vapor line, all the way to the outdoor unit, will be frozen solid. When the system's operating, when it's running, check the gauges. If you know your typical running pressures, you'll know something is off if you don't see those pressures in the range which you're used to seeing. So 410A, this is our gauges, 75 and 269. If you know the typical pressures, which we're going to talk about in a minute, then you'll know something is off or we're on point. Measuring your line temperatures. This is another good way to know if something is off and your system's low of refrigerant. We're measuring the vapor line temperature. We're measuring the liquid line temperature. Do we see a difference that's in the range that means that everything is good, or is it out of range? Another way to tell if the system's low of refrigerant is checking the temperature split. How do you do that? I use a pair of psychrometers. This one's gonna measure the return air. So the return air temperature is gonna be recorded. And then this one's gonna measure the supply air temperature. We're gonna check the temperature difference. If it's within the typical range, which could be anywhere from 18 to 22 degrees, then we know that the system is charged properly. But if it's 5 degrees or 10 degrees and the temperature is not very cold coming out of the vent, it's not cooling the home, that's an indication we've got a low refrigerant situation. Now, check out this coil. See how these tubes are freezing up? We need to charge this air conditioner. How do I know? I verified that the blower motor is running. We have good airflow coming out of the vents. I checked the filter. I made sure there's no issue with the filter. I checked across the filter dryer, which I'm going to show you how to do that. Made sure there's no restrictions. I know for a fact that we're low of refrigerant, and I'm going to show you using superheat and subcooling method how to charge this air conditioner. Let's cover everything that needs to be checked before we start the charging. First, is our outdoor fan spinning, compressor operating? Is our outdoor coil clean? Got to make sure it's clean. Checking the temperature difference across the filter dryer. Is there a temperature difference? If there is, that could indicate there's a restriction, and that could affect our charging. Check the air coming out of your vents. Make sure you got good airflow. Check your blower motor. Make sure it's operating correctly. Check your indoor coil. Make sure it's clean. Some of these coils, there's a little centerpiece you can take out to look inside to see underneath if that coil is dirty, because air comes through this side into the coil and then out through the top. Check your filter. Make sure your filter's not stopped up. Remember, we don't want to misdiagnose. So if we check all that, then we're going to make sure that we charge it, and that's the problem. Now we're going to look at all the temperatures and the pressures of this system right now before we charge it, so that you can see the difference. And you're going to be able to see the difference between the superheat and the subcooling. And I'm going to explain to you what superheat and subcooling is. First, we're going to get the temperature split. And you can measure at the vents, or you can measure at the unit. I like measuring at the unit. It's more accurate. You could lose some temperature through your ductwork or from this unit to the actual supply branch outlet. So we've got our return air. This is where our air comes in from the house, through the filter, and then into the equipment, and then it goes out through the supply. Return air is 72 degrees right now. So 72 degrees using the psychrometer. Our supply air temperature is 63. 72 and 63 right now. So as you can see, our temperature split between return and supply is around 9 degrees. Typically, we want to see 18 to 22 degrees. That's what I like to see. So to me, we don't have the right temperature split. Now that's the first measurement we're going to take. Now we're going to measure the pressures, the temperatures, and the condenser split. So our pressures are 80 and saturation's 21. I've got a set of electronic gauges, so I can adjust the refrigerant that I'm using based off of the equipment I'm working on, and then it gives me the saturation. We need that saturation. So 78 and 20. High side pressure is 269 and 88. Now we want to get the temperatures of both of our lines, the vapor line and the liquid line. The vapor line is 73.9. To get the superheat, we take 73 and we subtract from the saturation for that low side, the evaporator. So that was 20. So 20 and 73. That's 53. So that's our superheat. Remember that. Now let's look at our liquid line temperature. It's 86.5, right? 86.5. Now we need to know what our subcooling should be. And typically, if the system has a TXV, you can look at the data plate and it'll show you the subcooling that's required for this equipment, or what you should see. Now let's look at the data plate. If you look right here on the data plate, it says indoor TXV subcooling, 15 degrees Fahrenheit. That's what our subcooling should be. Now how do we get the subcooling? We take that liquid line temperature and we subtract that from our saturation on our high side. That's our condenser pressure, right? Our head pressure, discharge pressure. And I think it was 88. So 88, and let's recheck real quick, 88 and 87. That's only 1 degree. That's not good. So that could be an indication that we are low on charge. Now, what does superheat and subcooling mean? How do I look at superheat and subcooling? What does it mean to me? And how should you look at it so you can understand it better, use it to be able to charge systems correctly? And then what typical superheat and subcooling numbers do I want to see? So how do I look at, how should you look at it? It's the amount of refrigerant that's in the indoor coil and the outdoor coil. If this system's in cooling mode, we know the outdoor unit's the condenser and the indoor unit's the evaporator, right? We know that we need refrigerant in the condenser and we need refrigerant in the evaporator for the system to actually work correctly and cool your home. For superheat, we are looking at the evaporator and how much refrigerant is inside that evaporator. For subcooling, we're looking at the condenser and how much refrigerant is in that condenser. When I have a low subcooling number, let's say 0 or 1 or 2 or 3, then that means to me the condenser is empty, or there's not a lot of refrigerant in the condenser. If I have a high subcooling number, let's say it's 15 or 20 or 30, then that to me means that there is a full condenser. It's full of refrigerant. It's got plenty of refrigerant. It's not empty. It's not starved. Now, superheat is referring to the indoor coil, the evaporator. So if I have a high superheat number, and this might trip you up a little bit, but this is the way you got to look at it. Subcooling, The higher the number, the more refrigerant. The lower the number, the less refrigerant. Superheat is the opposite. So the lower the superheat number, let's say we have a superheat of 5, then our evaporator is full. If we have a high superheat number, let's say it's 100 or 50, then that means there's less refrigerant in the evaporator, and that evaporator may be empty. That's the way I want you to look at it from here on out. That is going to help you. Not the technical term or the definition. That does nothing for us in the field. We need to know if our subcooling is 0, we need refrigerant. If our superheat is 0, we have plenty of refrigerant. Now I hope you get it. Let me know in the comments if you do. I like to look at both superheat and both subcooling. I like to know how much refrigerant's in the indoor coil, the evaporator, and the outdoor coil, the condenser. Because if I see a high superheat, which means there's not enough refrigerant in the evaporator, and a low subcooling number, which means there's not enough refrigerant in the condenser, then I know for sure that it's low on charge. I'm not going to misdiagnose. But if I check both superheat and subcooling, and one's high, one's low, one's low, one's high, there could be a restriction. There could be something else wrong. And that's the reason in the beginning of this video, I wanted you to know what you should check. Let's check one more temperature here, and then I'm going to ask you a question, and then we're going to start charging. So this is what we're going to check. We're going to check with our psychrometers the condenser split. So this temperature is 93. 93. A little hard to see, but that's 93. Take my word for it. Then this temperature, and that was the discharge air. This one is 86. So 86 and 93. Remember that. That is 6 degrees for our condenser split. From the air that's being pulled in to the air that's being pulled out. All these temperatures are going to change. So let's take a look real quick at all the pressures and temperatures, and then let's start charging. So 80 PSIG and 273. 21 saturation subtracted by 71. That's 50 degrees of superheat. High superheat means what? Let me know in the comments. And then liquid line temperature is 87 and then 89. That means we've got a saturation 89 over here. That means it's 2 degrees of subcooling. We got 2 degrees of subcooling, which is low subcooling, which means we have not enough refrigerant in our condenser. And then high superheat, not enough refrigerant in the evaporator. Hopefully you got that right. Now, if you remember all these numbers, let's go ahead and set up the scales and get the refrigerant. Take your middle yellow hose and connect it directly to the tank. Make sure you screw it on tight, then open up the tank. You want to make sure that your gauges stay closed. Now you can flip the tank over onto your scales so you can charge liquid. If you flip it back over, you're charging vapor. You may need to charge vapor or liquid depending on what you're doing. Now we've got the refrigerant on the scales. Let's bleed the refrigerant by opening up the yellow hose. All the air's bled out. Now let's clear out our scales. Make sure they're on. Clear them out. Now we're ready to add some refrigerant. You can see that our scales say 0. We're set up to weigh the pounds. We can see that the pressure is 80. Now we're going to open up the valve, and you're going to see the pressure goes up while we're charging. Also, while we're charging, you're going to see the scales. You can see the ounces and the pounds. 8 ounces, that's half a pound. 16 ounces is a full pound. Charge, wait 10, 15 minutes, measure all your temperatures and pressures, and then recharge if you need to. All right, let's shut off at 1 pound. There's 1 pound. You can see right there on the scales, it says 1 pound. We have added 1 pound of refrigerant. Always weigh in the refrigerant. Never charge without scales. You're not treating the customer fairly, and you're not being as accurate as you could be when you're charging. Now that we've charged 1 pound, let's look at our pressures and temperatures. We added a pound of refrigerant. We waited about 10 minutes. Our pressures and temperatures probably changed. Let's check and see what our superheat and subcooling is now. Let's check the gauges. Low side pressure is 97. So that went up, I think, about 20 PSI. Saturation is 30. So that went up 10 degrees. So it was 20, now it's 30. High side pressure is 290. That was, I think, 270. And then the saturation's 93. It was 88, so it went up 5. Now let's check the temperature clamps. Suction line temperature, vapor line temperature, 70. So that's about the same. Liquid line temperature, 89. I think that was about 87. So that went up about 2 degrees. So if we've got 70 and 30, well, that's 40. So now our superheat has a lower number. It was 50, and that's better. That means we got more refrigerant inside of our evaporator. Then we've got our 89, and it was 92, 89 and 92. So before, I think we had like 2 degrees. Now we've got 3 degrees of subcooling. So we got more refrigerant in our condenser and our evaporator. Now let's check the temperature split inside. We're checking the temperature split. Let's see the difference. We've got 72 degrees coming into our unit through the return. That's our return air temperature. And we have got 59.9. So 72 and 59. That's 13 degree split. So since we've charged, we've got 3 degrees. Our supplier temperatures dropped 3 degrees. We got 3 degree colder air coming out of our vents into our home. Now before we charged, the coil was freezing up. You could see that. Let's just see. Looks like we don't have any ice and our coil is sweating. And it looks like it's sweating almost all the way up. I can see these tubes are not sweating. Okay, but these tubes are sweating, these tubes are sweating. So our coil is not completely full, but it's getting there. Be careful not to bump your scales while you're charging. It could provide you with an inaccurate reading like it just did me when I accidentally bumped it. So now I'm going to clear the scales again. And we know we've added a pound. I'm going to add another pound. So take a look at the scales. It says 0. And take a look at the pressures. Looks like we've got 96 and 284. Now let's go ahead and add. We're adding refrigerant. You can see our scales are changing. 2, 3. All right. What superheat and subcooling numbers should you be looking for? For a TXV system, your superheat should be in between 8 to 15. For a fixed orifice, it should be 10 to 20. For your subcooling, I'm looking for anywhere from 8 to 15 degrees. What happens when you have low superheat? When you have low superheat, you could be sending liquid refrigerant into the compressor where there should only be vapor going into the compressor. Then you end up washing the oil out of the compressor, and that compressor is no longer lubricated. So that reduces the lifespan of the compressor, potentially damaging the compressor, and then that oil gets logged in the evaporator. So then you have reduced cooling capacity, lack of performance, lower efficiency. What happens if you have low subcooling? If you have low subcooling, that means you don't have a steady column of liquid going to the TXV. What happens if you have high superheat? You don't have enough refrigerant going into your evaporator, so you got a starved evaporator. Then you don't have enough refrigerant to cool your compressor, so you have high compressor temperatures. Ends up leading to the compressor burning out. What happens if you have high subcooling? You got too much refrigerant. You have high head pressure. Then you have reduced cooling capacity. Make sure that your superheat and your subcooling numbers are lining up and you're on point with those numbers. That makes sure that you have long-term efficiency and good lifespan for your equipment. Now, hopefully you know the numbers before. If you don't, rewind the video, go check them out, and let's compare those numbers. Now we've added 3 pounds of refrigerant. We added 1 pound, cleared the scales, we added 3 more. So 4 pounds total. Before, our pressure on the low side was around 70. Saturation was, I think, 20. Now the pressure is 128. This is 410A. Our saturation is 44. So let's stop there and let's find out what our superheat is. So how do we do that? We go over to our vapor line temperature and it says 57. All right, so 57 subtracted by, what was our saturation on the low side? 44. So that means that our total superheat is, I think, 13 degrees. Hopefully I'm doing my math correctly there. 47 and 57 will be 10, 3 more degrees, that's 13. There you go. So that means our superheat is 13 degrees. We subtracted the saturation temperature from our low side pressure gauge from our suction line temperature, our vapor line temperature. And that means our superheat's not too high, the number's not too low, it's just right. It's in between the 8 to 15 degrees that I like to see. Since we're using that TXV, that's what I'm gonna use for my numbers, 8 to 15. We're not using a piston. If you don't know what a TXV is, I'm gonna show you that in today's video. Now let's check the pressure on the high side, the discharge pressure, and compare that with our liquid line temperature. Now let's figure out our subcooling. We're gonna check out our high side pressure, which is 312, 313, and our saturation, which is 98.7. So remember that, 98.7, and then let's go over here and check the liquid line temperature, which is 92.6. So we got 6 degrees of subcooling, which is a lot better than 2 or 3. So we've got a lot more liquid in our condenser. Now let's go inside and check the temperature split. We're checking out our return air and our supply air temperature, and then we're subtracting that to see if we're in the 18 to 22 degree range. So the return air temperature, that's the air we're pulling in, is 70.5. Our supply air temperature, the air we're pushing out of our system, is 50.0. So we've got a 20 degree difference. And before we started charging, it was only 10 degrees. So we have decreased that air temperature 10 degrees. We've lowered the air temperature, we've made the air much colder, and now it's gonna feel a lot better in the home. It's gonna be able to cool during those 90 degree days. You saw the temperature difference inside, now check this out. So before, our suction line temperature was like 70, and our liquid line temperature was 80. But now you can see there's a greater difference. 56 and 92. That's almost a 40 degree difference. It's over 30 degrees. Instead of 10 degrees, it's 30 degrees. What does that mean? We're actually, since we're properly charged now, we're actually absorbing more heat inside and rejecting more heat outside. We're moving more energy. Now let's check our condenser split. Before, when we measured our condenser split, which is our entering and our leaving temperature, it was only 6 degrees. Now let's check it. Let's do our leaving temperature first. Leaving air temperature is 100.4. Now let's measure the entering air temperature. It is 86. Wow. So we've increased that temperature split. It went from 6 to 14. That's amazing. That means we're rejecting more heat. Let me show you a TXV valve. This system uses a TXV. This is a thermostatic expansion valve. Not all systems have the same metering devices. They could have a fixed orifice, a fixed metering device, an EEV valve, an electronic expansion valve, or a TXV, a thermostatic expansion valve. They all meter the refrigerant in the system. If you have to charge a system and it's low of refrigerant, that means it has a leak. Refrigerant doesn't just disappear, all right? There's a leak. You have to be able to find that leak and fix that leak. And if you don't know how, I'm gonna put a link in the description to a video where I show you how to find a refrigerant leak. Go check it out and learn more. Let's go over this real quick. You show up to the job. How do you know it's not charged without even hooking anything up? Put your hand over the outside fan, the condenser. Should be warm air coming out, but it's not. Take your hand, put it on the larger line, that vapor line. Should be cold to the touch. It's not. Check the liquid line. Liquid line's not warm. Maybe it's a little cool. That's not right. You go inside. You put your hand over the supply vent. It's not blowing out cold air. Should be, but it's not. You check all that, you know for a fact before you even put your gauges on the system that something's wrong. It might not be that it's low on charge. It may be something else. But you need to be checking these things. That way you know where to look first. You go inside, the indoor fan's not running. You go outside, the outdoor fan's not running. What's not running? Start from there. Start from the beginning. Also, remember guys, before you do any work, make sure you're wearing the proper PPE. That way you're safe. Now you know what to look for. Now you know what to check. Now you know the symptoms of a system when it's low on refrigerant. Now you know what tools to use. You know what superheat and subcooling means. You know how to figure it out by subtraction of the saturation temperature, the line temperature. You know what tools to use. You know how to use them. You know how to charge an air conditioner. Let me know in the comments if you like this video. If you like the video, hit the like button, subscribe, smash that bell, ding, so you know what I'm doing. You got a question? Remember, questions can lead to new content. So put your questions down below. If you don't have a question, that's okay. Let me know who you are and let me know where you're from. If you want more videos like this, go check out my playlist, HVAC Tips for Technicians. I've got hundreds of videos of live experience as a technician in the field to help you be a better technician. You've been watching HVAC Tips for Technicians. I'm Tad. This was Taddy Digest, and I'll keep you cool if you let me.